Hello everyone, myself Kaddam Sandhukrishna, working as an assistant professor at Maleni Perumalu Educational Society's group of institutions. Today I am going to tell you about an overview of impact of jet. What do you mean by impact of jet? The liquid comes out in the form of jet from the outlet of a nozzle which is fitted to a pipe through which the liquid is flowing under pressure. If some plates, which may be fixed or moving, is placed in the path of the jet, force is exerted by the jet on the plate. This force is obtained from Newton's second law of motion or from impulse moment equation. Thus, impact of jet means the force exerted by the jet on the plate, which may be stationary or moving. Here are the two cases: the force exerted on the jet. The first case is force exerted by the jet on a stationary plate. Here are three conditions. That is, plate is vertical to the jet, plate is inclined to the jet, and plate is curved. And another one is force exerted by the jet on a moving plate. Here also there are three conditions. First one is plate is vertical to the jet, plate is inclined to the jet, and the plate is curved. Coming to the case 1 and condition number 1. Force exerted by the jet on a stationary vertical plate. Let us consider a jet of water which is coming from the outlet of the nozzle fitted at the pipe strikes a flat vertical plate as shown in figure. Here, this is the pipe and this is the nozzle which is fitted to the pipe. Now the water is coming from the nozzle, jet of water, and striking the vertical plate. This plate is fixed. The velocity of the jet is v and the diameter of the jet is d, and the area of the cross section of jet is pi by 4 d square. Here the jet of water strikes the plate and moves along the plate. Here the plate is kept at 90 degrees so that if water also get deflected through 90 degrees. There is no component of velocity here. Therefore, the force exerted by the jet on the plate in the direction of jet is Fx. Here the force is in horizontal direction. So Fx equal to rate of change of momentum in the direction of force. I already told you that in the introduction part, the force exerted by the jet is due to Newton's second law or impulse moment equation. So the equation is Fx equal to initial momentum minus final momentum by time. Here initial momentum is mass into initial velocity. Final momentum is mass into final velocity by time. In these two equations, mass by time is common. So I have taken out mass by time into initial velocity minus final velocity. What is initial velocity? The velocity of the jet before striking, and final velocity, it is the velocity of the jet after striking. That means the equation becomes mass by time into velocity of the jet before striking minus velocity of the jet after striking. By simplifying, by substituting the values, we get rho AV into initial velocity of the jet before striking is v, and final velocity of the jet after striking is 0. By simplifying this, we get Fx equal to rho a v square. Now let us solve the problem. Find the force exerted by the jet of water of diameter 75 mm on a stationary flat plate when the jet strikes the plate normally with a velocity of 20 meters per second. We have to write given data. What is the given data here? Diameter of the jet is 75 mm. D equal to 75 mm and velocity is 20 meters per second. V equal to 20 meters per second. Here, diameter is represented in mm and velocity is represented in meters. So we have to convert diameter or velocity into same units. Now I am converting diameter 75 mm into meters, that is 0.075 meters. Therefore, area equal to pi by 4 d square. Substituting the d value in area, we get the area A equal to 0.04417 meter square. What we have to find here? The force exerted by the jet. The force exerted by the jet on a stationary vertical plate. The equation is F equal to rho A V square. For water, rho equal to 1000 kg per meter cube. Therefore, substituting, we know the value of rho, we know the value of A, and we know the value of V square. Substitute all the values in this equation, we get F equal to 1000 into 0.00417 into 20 meter square. We get F value as 1766.8 newtons. Force always represents in newtons. Coming to case 1 and condition number 2, that is force exerted by the jet on a stationary inclined plate. Let us consider a jet of water which is coming from the outlet of the nozzle fitted to the pipe strikes a flat inclined plate. V is the velocity of the jet in x direction and d is diameter of the jet. A is area of cross section, that is pi by 4 d square. Theta is the angle between jet and plate. This angle is theta. Let us determine the mass of water per second striking the plate is rho AV. Let us assume that the plate is inclined and smooth and there is no loss of energy due to impact of jet. Considering this assumption, we say that jet will move over the surface of inclined plate after striking the plate with a velocity equivalent to the initial velocity. That means the jet strikes the plate inclinedly and moves along the plate. Now the initial velocity is v. This theta is the angle between the plate and jet. It is, if we see this is 90 degrees. So we resolve the components of our velocity. This side the velocity component is v cos theta and here the velocity component is v sin theta. Here the Fn is the force exerted by the jet in the direction normal to the plate. Here the plate is like the incline and Fn is normal to the plate. Therefore, Fn becomes mass of the jet striking per second into initial velocity of the jet before striking in the direction of n minus final velocity of the jet after striking in the direction of n. Before striking, initial velocity of the jet before striking is v cos theta. Final velocity is 0. Substituting the values, Fn becomes rho a v into v sin theta minus 0. Simplifying this, we get Fn equal to rho a v square sin theta. Now we will solve the force components in horizontal direction, that means in the direction of the jet and perpendicular to the direction of jet. In the direction of jet means horizontal direction x and perpendicular to the direction of jet is y. Now the force component Fx in the direction of jet, this is Fx. This becomes, here it looks like Fn components. This is the resultant Fn. So here the force exerted in horizontal direction will becomes Fn cos theta. Here the theta is 90 degrees minus theta. That means Fn equal to, Fx equal to Fn cos 90 minus theta. Cos 90 minus theta becomes sin theta. Substituting the Fn value, we get rho AV square sin theta into sin theta. That means Fx equal to rho AV square sin theta. And component of force in perpendicular direction to the jet. For perpendicular direction, that means here in this direction. This is the perpendicular direction. Okay, this is Fn cos theta. Here the vertical component, it is Fn sin theta. Fn sin theta. The theta value here is 90 minus theta. Substituting this, Fn sin 90 minus theta. Fn sin 90 minus theta means Fn cos theta. Substituting the Fn value, we get rho AV square sin theta into cos theta. A jet of water of diameter 75 mm moving with a velocity of 25 meters per second strikes a fixed plate in such a way that the angle between jet and the plate is 60 degrees. Find the force exerted by the jet on the plate in the direction normal to the plate and in the direction of jet. Question: the diameter of the jet is 75 mm. Here diameter is 75 mm. I am converting the diameter mm units to meters. That means 0.075 meters. Now the area becomes pi by 4 t square. Substituting the value of t, we get area is 0.004417 meters square. They had given velocity of the jet is 25 meters per second. V is 25 meters per second. And they also given the angle between the jet and plate is 60 degrees. That means theta is 60 degrees. What they are asked to find? The direction normal to the plate. That means they are asked to find Fn value. What is the value? What is the equation for Fn? Fn equal to rho A V square sin theta. We know the value of rho, A, V and theta. What is the value of rho? Rho is density of water, that is 1000 kg per meter cube. Substituting the values in Fn means 1000 into 0.004417 into velocity square. V is 25 square into sin theta. Then we get Fn as 2390.7 newtons. Remember one thing, force should be in newtons or kilonewtons. Don't forget to keep the units. Now they also ask it in the question that find the force exerted in the direction of jet. What in the direction of the jet means? Horizontal direction. That means Fx. What is Fx? Rho a v square sine square theta. Substitute, we know the value of rho a v square and theta. Substituting these values 1000 into 0.004417 into 25 square into sine theta, we get the force in the direction of the jet is 2070.4 newtons or 2.0704 kilonewtons. Case 3 and condition number 3, that is force exerted by the jet on a stationary curved plate. In this condition there are again three conditions. One is jet strikes the curved plate at the center, and jet strikes the curved plate at one end and tangentially when the plate is symmetrical, and jet strikes the curved plate at one end tangentially when the plate is symmetrical. In case 1, condition number 3, there are again three conditions. The first one is when the jet strikes the curved plate at center. Let us consider that a jet of water strikes a fixed stationary plate at its center as shown in the figure. This is the fixed curved plate and jet strikes the curved plate at center. Let us assume the following data. The velocity of the jet is v and the diameter of the jet is d. Therefore, The area of cross section of jet is pi by 4 d square. Theta is the angle made by the jet with x-axis. Let us assume the curved plate is smooth. So there is no loss of energy due to impact of jet. The water strikes the jet, then the velocity component from at the outlet of the jet is tangential direction to the curved plate. Like this. This is the tangential direction to the curved plate. By resolve the components of velocity in the direction of jet, that means in the direction of jet and in the direction in perpendicular to the jet. The velocity component in the direction of jet is v cos theta. Here the direction represents against the jet. So the velocity component to the horizontal is minus v cos theta. Here minus v cos theta. Now the vertical component perpendicular to the direction of jet is v sine theta. That is here v sine theta. Now let us do a problem on curved plates. A jet of water of diameter 50 mm moving with a velocity of 40 meters per second strikes a curved fixed symmetrical plate at center. Find the force exerted by the jet of water in the direction of jet if the jet is deflected through an angle of 60 degrees at the outlet of the curved plate. Given data. Diameter of the jet d equal to 50 mm. Now I am converting 50 mm into meters, that is 0.05 meters. Now the area of the jet is A equal to pi by 4 d square. Substituting the d value, we get area as 0.001963 meters square. They had given the velocity of jet. What is the velocity of the jet? 40 meters per second. V is 40 meters per second. And theta is deflected angle at the outlet. Means this is the jet, this is the curved plate, and this is velocity. This is theta, outlet of the jet. What is theta? 60 degrees. So force exerted by the jet on the curved plate in the direction of jet. In the direction of jet, the equation is Fx equal to rho a v square into 1 plus cos theta. We know the value of rho, we know the value of A, V square and theta. Substituting these values, we get Fx equal to 47111.15 newtons. Coming to the condition 3. In this condition, jet strikes the curved plate at one end tangentially when the plate is symmetrical. Let us consider that the jet of water strikes the fixed curved plate at one end tangentially when the plate is symmetrical, here as shown in the figure. Let us assume the velocity of the jet is v and theta is the angle by the jet with x-axis. Here the plate is symmetrical. So theta is the angle made with x-axis at the inlet of the jet and at the outlet of the jet. Let us also assume that the plate is smooth. Here the vertical plate is smooth. So therefore there is no energy losses due to impact of jet. Therefore the velocity at the inlet and at the outlet be same, that is V. Force exerted by the jet in the direction of x-axis. Here in the direction of x-axis. This is x-axis Fx and this is opposite to the direction of jet, vertical opposite direction. So force exerted by the water in the direction of jet. We have to find the force in horizontal direction. Here the jet is flowing with an angle theta. So resolving components, we get horizontal component as v cos theta at the inlet, and also at the outlet the velocity component is minus v cos theta. Here minus indicates the direction of velocity. That implies initial velocity is v cos theta and final velocity is minus v cos theta. Fx equal to mass per time into initial velocity minus final velocity. Substituting initial velocity value and final velocity value, we get Fx equal to rho a v into v cos theta minus of minus plus v cos theta. V cos theta plus v cos theta. Fx becomes 2 rho a v square cos theta. Now, the force exerted by the water jet in y direction. Here, y direction. It is perpendicular to the direction of jet. Jet is in horizontal direction and we have to find the force in vertical direction. Now, initial velocity at the inlet is resolving the velocity component perpendicular to the direction. Velocity is v sin theta. And at the outlet also the velocity component is v sin theta. So initial velocity is v sin theta and final velocity also v sin theta. Fx equal to mass per time into initial velocity minus final velocity. Substituting initial velocity value and final velocity value in Fy. Fy equal to rho a v into v sin theta minus v sin theta. Here negative, this v sin theta and this v sin theta get cancelled. Then Fy equal to 0. Coming to the next topic, jet strikes the curved plate at one end tangentially when the plate is unsymmetrical. So let us consider that jet of water strikes a fixed stationary plate, curved plate at one end tangentially. When the plate is here, the plate is unsymmetrical as shown in the figure. Let us assume the velocity of the jet is v and theta is the angle here. I am drawing here. This is the velocity of the jet v, and theta is the angle made by the tangent with x-axis at the inlet of the jet. This is jet inlet. At the inlet, angle made with the horizontal is theta, and at the outlet of the jet, the angle made with horizontal is phi, because the plate is unsymmetrical. Let us assume that the curved plate is smooth. So there is no loss of energy due to impact of the jet. The velocity at inlet of the jet remains constant at outlet also. Now, the force exerted by the water jet in x direction. Here, in the direction of jet, we have to find the force in the direction of jet. This is y perpendicular to the direction of jet, and this is x in the direction of jet. So Fx equal to mass per time into velocity component, initial velocity in x direction minus final velocity in x direction. Here initial velocity is at inlet. Here this is the inlet diagram I am drawing here. Velocity makes an angle V, makes an angle theta with the horizontal. So here the velocity component is V cos theta. So initial velocity is V cos theta. And at the outlet, here this is the outlet, the velocity component V, and the angle made with horizontal is phi. So horizontal component final velocity is V cos phi. Substituting the initial velocity and final velocity in Fx, we get Fx equal to rho a V into V cos theta plus V cos phi. In this equation, here V cos theta and V cos phi, V is same. So take out V from the equation. Now we get Fx equal to rho a V square into cos theta plus cos phi. Now we have to find the force perpendicular to the direction of jet, that is Fy. Fy equal to mass per time into initial velocity minus final velocity. Here in the direction perpendicular to the direction of jet, initial velocity is v sin theta, and at the outlet final velocity is v sin phi. Substituting initial velocity and final velocity values, we get Fy equal to rho a v into v sin theta minus v sin phi. In this equation, v is common. Take out v. We get Fy equal to rho a v square into sin theta minus sin phi. Now we solve the problem on jet. A jet of water of diameter 75 mm moving with a velocity of 30 meters per second strikes a curved fixed plate tangentially at one end at an angle of 30 degrees to the horizontal. The jet leaves the plate at an angle of 20 degrees to the horizontal. Find the force exerted by the jet on the plate in horizontal and vertical direction. What is given? The diameter of the jet, that is 75 mm. So D equal to 75 mm. I am converting mm into meters. We get D equal to 0.075 meters. Now area equal to pi by 4 D square. Substituting the value of D in A, we get area equal to 0.004417 meters square. Always we have to mention units. Now in the given data, velocity is 30 meters per second. That implies v equal to 30 meters per second, and the angle made with horizontal at inlet is 30. That means theta is 30, and the angle made at outlet is 20 degrees. So phi value is 20 degrees. Force exerted by the jet Fx equal to rho a v square into cos theta plus cos phi. We know the value of rho, we know the value of A, we know the value of V, we know the value of theta, and we know the value of phi. Substituting the values, that implies 1000 into 0.004417 into cos 30 degrees plus cos 20 degrees into velocity square 30 square equal to, we get Fx as 7178.2 newtons or 7.17 kilonewtons. In the same way, the force exerted by the jet perpendicular to the direction of jet, that is Fy. F, formula for Fy equal to rho av square into sine theta minus sine phi. Substituting the rho value, a value, b value, theta value and phi value, we get F value as 628.13 newtons. Coming to case 2, condition number 1. Force on a flat vertical plate moving in the direction of the jet. Let us consider a jet of water strikes the flat moving plate with a uniform velocity away from the jet. This is the velocity of the jet. The velocity of the jet is v. And when the water strikes the plate moves with a velocity u. U is the uniform velocity of the plate. Therefore, relative velocity with respect to the plate is v minus u. Mass of water striking per second on the plate equal to rho a into v minus u. Force exerted by the jet on moving plate in the direction of jet is Fx in the direction of jet, means jet moves in horizontal direction. So force is in horizontal direction is Fx. Fx equal to mass of water striking per second into initial velocity minus final velocity. Here we will take relative velocity. Initial velocity is v minus u and final velocity is 0. So substituting initial velocity and final velocity, we get Fx equal to rho a into v minus u into v minus u minus 0. That implies, by simplifying these, we get Fx equal to rho a v minus u whole square. For the stationary plates, the work done is 0. The work done is 0 because the plate is fixed. In the case of moving plates, work done by the jet is calculated as force into distance in the direction of force by time. That means work done W equal to F into D. Substituting the F value and D value, we get W equal to rho A V minus U whole square into U. Let us solve the problem. A jet of water of diameter 10 centimeters strikes a flat plate normally with a velocity of 15 meters per second. The plate is moving with a velocity of 6 meters per second in the direction of jet and away from the jet. Find the force exerted by the jet on the plate and work done by the jet on the plate per second. Also find the power and efficiency of the jet. We have to write given data. Diameter of the jet is d equal to 10 centimeters. So d is 10 centimeters. I am converting centimeters to meters. Therefore d equal to 0.1 meters. Area, we have to calculate area. Area A equal to pi by 4 d square. Substituting the value of d in pi by 4 d square, we get area. A equal to 0.007854 meter square. In this question, they had given the velocity of the jet is, that means the velocity of the jet V is 15 meters per second and the velocity of the plate is 6 meters per second, that is U equal to 6 meters per second. We have to calculate force exerted by the jet on the plate. That means Fx equal to rho A into V minus U whole square. We know the value of rho. For water, rho value is 1000 kg per meter cube. A is area. V is velocity of the jet and u is velocity of the plate. Substituting all the values, that implies 1000 into area 0.007854 into 15 minus 6 whole square. We get Fx equal to 636.17 newtons. And we also have to find work done. We know the formula for work done. W equal to Fx into U. We get the value Fx 636.17 into U value 6. Multiplying these, we get W as 3817.02 Newton meter per second. Find the power and efficiency. Power P equal to work done by per second by 1000. We know the value of W, work done. Substituting W value divided by 1000, we get power equal to 3.817 kilowatts. Power is measured in kilowatts. Next, efficiency of the jet. Formula for efficiency is output of the jet per second divided by input of the jet per second. Here, output means work done. We know the value of work done. Input means kinetic energy. Formula for kinetic energy is half into mass per second v square. We know mass per second is rho a v. Substituting the values 1 by 2 into rho a v into v square, we get half into rho a v cube. Kinetic energy, that means input power, is half into rho a v cube. We know the value of rho a and also v. Substituting the values, we get 1 by 2 into 1000 into 0.007854 into 15 cube. Now the efficiency of the jet is output of the jet means work done. The value is 3817.02 divided by input value. The value of input is 13,253.6. We get 0.228. Efficiency is measured in percentage. Therefore, efficiency of the jet is 28.8%. Coming to case 2, condition number 2. Force on flat inclined plate moving in the direction of jet. Here the condition is inclined plate. Let us consider a jet of water strikes the inclined plate moving in the direction of velocity, in the direction of jet. Here v is the velocity of the jet and u is the velocity of the plate. Water strikes the inclined plate and the plate moves in the direction of jet. Relative velocity with respect to plate is v minus u. V minus u is the relative velocity and a is the cross-sectional area of the jet. We assume that the plate is smooth, so therefore there is no loss of energy due to impact of jet. So the relative velocity at the inlet is v minus u and the relative velocity that leaves the inclined plate is also v minus u. Now let us see the force exerted by the jet on inclined plate in the direction normal to the jet. Okay, now I am drawing the here diagram. This is the direction of jet, that is Fx, and this is direction perpendicular to the jet, that is Fy. This is the inclined plate. I am drawing inclined plate in sky blue color. So this is the plate. This sky blue color represents inclined plate, and the angle between the plate and jet of water, this is angle is theta. If this angle is theta, then this becomes 90 minus theta. Okay. Now the force in normal direction to the plate. This is the normal direction to the plate. This is normal force, that is Fn. Okay, Fn is a normal force. We know the formula for force Fn, that is
mass of water striking per second into initial velocity minus final velocity. In stationary plate condition, we have used only velocity, but in moving plate conditions, we are using relative velocity in the place of velocity. So mass of water striking per second formula is rho A into V minus U. Here V minus U is relative velocity into initial velocity minus final velocity. Here initial velocity is V minus U. Okay, V minus U is the initial velocity, and here the angle is 90 minus theta. Okay, remember this angle is 90 minus theta, and this angle is theta. This again, this angle is 90 minus theta. And this angle is theta. We have to find the force, we have to find the initial velocity in Fn direction, Fn, that is V minus U into sine theta minus final velocity. There is no final velocity in normal direction. Yes, see, this is the normal direction. So there is no final velocity. So the final velocity is 0. Then the normal direction force becomes Fn equal to rho A into V minus U whole square sine theta. Now we have to find the force in the direction of z and perpendicular to the direction of z. In the direction of z means, see here, this is the direction of z and this is perpendicular direction. So x is in the direction of z. The water flows in horizontal direction only. So direction of z means of x. See here, this is Fn, and here the angle is 90 minus theta. What? Here the angle is 90 minus theta, and this is Fn. Resolving the forces in the direction of z, that means in Fx direction, we get Fx equal to Fn into, here this is 90 minus theta. By resolving this, we get here cos 90 minus theta. 90 minus theta. Cos 90 minus theta indicates sin theta. That implies Fx equal to Fn into sin theta. Substituting the Fn value, we get Fx equal to rho A V minus U whole square into sin square theta. In the same way, we have to find the direction perpendicular to the z. This is the perpendicular direction. Okay, here the angle is theta. So this is also perpendicular direction. Here the force will become Fn into, here this is the angle 90 minus theta, means here we can write Fn sin theta, Fy equal to Fn sin theta. Substituting Fn value, we get Fy equal to rho A V minus U whole square into sin theta. Now we have to find work done. What is the formula for work done? Force into distance. Force means Fx into distance. The distance is U. Substituting the Fx value, we get work done equal to rho A into V minus U whole square sine square theta into U. This is the work done formula. for inclined moving plate. W equal to rho A into V minus U whole square sine square theta plus, into U.
Now let us discuss a problem on inclined plate. A 7.5 centimeters diameter jet having a velocity of 30 meters per second strikes a flat plate normally of which is inclined at 45 degrees to the axis of the jet. Find the normal pressure when the plate is stationary and when the plate is moving with a velocity of 15 meters per second away from the jet. Also determine the power and efficiency of the jet when the plate is moving. First of all, we have to calculate the normal pressure. There are two conditions here given in the question. What is the first one? When the plate is stationary, and second one when plate is moving with a velocity of 15 meters per second. In the question, diameter D equal to 7.5 centimeters. D equal to 7.5 centimeters. Converting centimeters into meters, then D equal to 0.075 meters. We know the value of D. Therefore, area equal to pi by 4 D square. Substituting the D value, we get area A equal to 0.004417 meter square. I am drawing the diagram here. This is inclined plate diagram. See, this is the inclined plate. And they ask to find Fn, normal force. This is Fn. Here the angle between the plate, this theta value is given. The angle between jet and the plate is theta 45 degrees. Therefore, in the question, velocity of the jet is given v equal to 30 meters per second. What they have asked? Normal pressure Fn for stationary plate and moving plate. So first I am solving for stationary plate. Formula for stationary plate Fn equal to rho a v square sin theta. We know the value of rho. We know a value and also v square value and sin theta value. Substituting the values, rho equal to 1000 into area 0.004417 into velocity 30 square into sin 45. We get Fn value 2810.96 newtons. We can also convert newtons into kilonewtons. That implies 2.81 kilonewtons. For moving plate, the velocity of the plate is given, that is u equal to 15 meters per second. Formula for Fn equal to rho a into v minus u whole square sin theta. We know rho value, a value, v minus u whole square and sin theta. Substituting the values, 1000 into 0.004417 into here v 30 minus u 15 whole square into sin 45. We get Fn as 702.74 newtons. They also asked us to determine power and efficiency. Formula for power. Okay, here first of all we have to calculate work done. We know the formula for work done. What is that? Force into distance. Here force is horizontal force. We have to use force, horizontal force. Work done W equal to Fx into U. We know F value and also we know U value. Substituting the values, work done equal to 7453.5 Newton meters per second. We have to calculate power. Units of power is kilowatts. Power equal to work done per second divided by 1000. That implies work done 7453.5 divided by 1000 equal to 7.453 kilowatts. Now efficiency of the jet. What is the formula for efficiency? Output by input. What is output? Work done. What is input? kinetic energy. We know the value of work done. We have to calculate kinetic energy. What is the formula for kinetic energy? Half into mass per time into v square. That implies half into rho a v into v square. Substituting the values, work done 7453.5 divided by half into row value 1000 into area 0.004417 into velocity 30 meter cube. By calculating this, efficiency equal to 0.1249. That implies efficiency should be represented in percentage. Therefore, 12.5 percentage.
With this, we have completed an overview of impact of jet. Thank you for spending your valuable time with us. Kindly answer the questionnaire form. The link is given in the description box for getting your participation certificate. Thank you. Stay home, stay safe.